Hi, in today's video we'll be solving a few challenges from AndroGoat, which is an Android application written in Kotlin and designed for security testing. So how do we download it? Go to the release section and download the APK. Then just copy the path and type this command adb install and give it the path for AndroGoat APK. Now that we are inside the application, we'll start solving a few challenges. Let's begin with the hard decoded issues. First, let's solve a shopping cart challenge. As you can see, the objective is find out how, where promo code is hard decoded, enter promo code to get all the product for free. So they want us to find something called a promo code inside the source code. It's a good way to look for hard decoded issues like password, API keys, anything interesting, and purchase this watch for free. So let's see the source code. As you can see, it's a lot to look for. There's a lot of activities here. So we will use this search function in JADX. So right now it's obvious what we are going to look for. They asked us to look for something called a promo code inside the source code. But in real application, it's not the case. Most of the time, you don't know exactly what to look for. So maybe look for API keys, password, maybe tokens, or maybe be a little bit creative and use regex. The JADX GUI let you use regex to look for a lot of things. If you want to look for everything inside the source code, classes, method, field, code, resources, comments, or you want to specify just the comments part. So let's see if we will find the promo code inside the comments part. Promo code. Unfortunately, we didn't find anything, so we can select all these boxes. Oh, we already found it. Promo code in year 2019. So let's guess this is the promo code. Let's type it to figure out if it's the real one or not. Year 2019. So we are able to purchase this watch for free. We found the promo code inside the source code. It's hard decoded. There's a few challenges there. We have AI chat, we have view cloud services. The objective is find out how where OpenAI API key is hard decoded. View cloud services, they want us to look for AWS key and secret key. So you can look for API key, cloud services. I'm not going to solve it. You can try to solve it by your own, but let's search for API key inside the cell code. So if you only search for API, it will give you a lot of results. You cannot look for all these results. It gives you 2,000. So you can use regex. You can uncheck this box, maybe look for only the code, or if you want to look for classes. So this is all the classes that include API. You can remove the case sensitive to only look for API with all lowercase. So they give us 85 results. So let's search for API key. Okay, we already got it. OpenAI API key, and this is the key here. You can look for cloud services too. Maybe you can look for cloud classes, activities. Maybe you'll find AWS key or secret key inside it. In this challenge, we are going to explore unprotected Android components. The objective is to understand components that are unprotected or exported, and how we can download an invoice without PIN verification. So, exported activities are components of an Android app that can be accessed by other apps. If an activity is exported and not properly protected, it can be accessed without any checks. So I'll give you an example. As you can see here, we have to give it the right PIN to log in. Let's try to give it any PIN. Incorrect PIN entered. So if we have the right PIN and we entered it, it will redirect us to the invoice page. And let's be more creative and imagine this invoice page is exported. What does that mean? We can access this page without needing to give it the right PIN. So this is what exported activities mean. So any page that are exported and not properly protected, or they don't ask for specific permission, we can access it by other apps. And in this challenge especially, we're going to use a tool called Drowser. It will allow us to enter these activities. But how we look for these activities, we can look in the source code, or Drowser will make it more easier to look for these activities. We can look in the source code for exported activities. We can look for exports to true, and as you can see, we have access control view activity is exported, and we have the splash activity exported too. Now let's move on to Drowser and check the activities. But first we need to make sure the Drowser agent is running. Make sure it's running. And it's running on port 31415. And then we have to use this command to forward the port so Drowser can communicate with the agent on the emulator. Now that we're connected to Drowser console, we can see all available modules. You can connect to the Drowser console via this command. But before we dive in, let's quickly look at Drowser commands. Drowser has modules for inspecting apps like activities, services, content providers, and packages. For example, app.package.list. It will list all packages. App.activity.info. It will get information about exported activities. And we have app.package.attack services. It will get the attack services of packages available on the application. But first, let's check the packages on the application. Run. It'll give you a lot of packages, but you can type -h to look for a specific thing, and as you can see, we can provide -f to filter out. So let's give it -f and look for goat, because we are using AndroGoat application. And we get the package name of AndroGoat application, os.set.agoat. So let's copy it because we need it. Let's look for the attack services on the application. So run app.package attack services. -h to look for a specific thing. We just have to give it the package name. So let's copy the package name, run it again without -h. And as you can see, we have 2 activities exported, 2 broadcast receivers exported, we have 1 service exported, and the application is debuggable. That's interesting. So let's look more into the activities. And we have this app.package. Not package, let's look again on the modules. We have app.activity.info. It will give us an info about the package and the activities exported. Run. So we have to provide that -- package and give it the package name. Okay, we have 2 exported activities. We have the splash activity and the permission is null. And we have the second activity called access control view activity that we saw it earlier in the source code. So how we can access this activity? If we go back to the command, we can see that we have app.activity.start. So let's copy it. Run -h. So they ask for a -- component, give it the package name, and we have to give it the activity name. So -- component, give it the package name, os.set.agoat, and our activity. Let's first see what splash activity is. Make sure you are in a Drowser. Okay, the splash activity is the main one, so it's secure to be exported. It has to be exported so we can access it. So let's look for the other activity. We have to return back to Drowser, run the then the command again. Okay, welcome user, please download invoice. We are able to get to the invoice page without needing to give it the right pen. Okay, let's move on to the final challenges: network intercepting and root detection. We'll start first with root detection. But first, let's understand what root detection means. A root detection is a security mechanism that checks whether the device is rooted. If the application detects a rooted device, it can block you from accessing the application. So when we click on check root button, it will give us this pop-up said device is rooted. So how we can bypass the security mechanism? By using Frida. It's a huge repository with a lot of scripts. So here we have a lot of scripts. Frida multiple bypasses, multiple unpinning, we had a Frida anti-root. We can use this to bypass the root checks here. So let's test it out. Just copy this command. But first we have to know what the package name is. So run this command to give us a list of the packages. So the package name for AndroGoat was.set.agoat. After we got the package name, return back to Frida code share, copy this command, Frida-code share, give it the package name, and make sure to add -u. Why should we add -u? To tell Frida to attach to a device connected via ADB. Without it, Frida can't find our application. It won't find AndroGoat because it doesn't know which device to target. The -u option ensures Frida connects to the correct device, whether it's an emulator or a physical device. So make sure to add -u because if you try to not add it and run it won't, as I told you, it doesn't find OWASP.set.agoat. But if you return and give it -u, it was able to find our app. If you return back to... So let's go to root detection. Let's click on this button, and as you can see, device is not rooted. We're able to bypass this detection. So as you can see here, it bypassed the root detection. The last challenge we have is network intercepting. We have HTTP, HTTPS, and certificate binning. We only have to click on it to see if we got traffic or not. Make sure the intercept is on. If we click on HTTP, it will send a request to demo.testfile.net. Why we be able to see the traffic? Because HTTP is not encrypted, so it can be easily intercepted. If we click on HTTPS, it will also send a request to OWASP.org. We were able to intercept the traffic because even though HTTPS is encrypted, it requires a trusted certificate. Since we installed the BERB certificate, we were able to intercept and view the traffic. But for certificate binning, it won't send any request. We can bypass it by using Frida scripts. You can use this script, Frida Android unpinning SSL. Just copy this command, run it. Okay, let's click on it. As you can see, we got traffic, and we bypassed certificate pinning or SSL pinning. But sometimes you're not only checking for certificate pinning, sometimes they check for root detection, certificate pinning, maybe more than that. So you can use your own script, like I did here. I just copied the Frida anti-root script and the Frida Android unpinning SSL. I put them in one file. Let's run it. If you return back to the application, let's check first for root detection. As you can see, we're not rooted anymore. And if you return back to network intercepting, certificate binning, we send a request to this link. So we are able to bypass both certificate binning and root detection